Hi, everyone. Thanks for the many people that seem to be interested in this talk. Very cool. Yeah, let's get started. I have a quick agenda, but it's the usual thing. A quick motivation, then the actual concept. Then I will talk a bit about the implementation and what types of technology you can do. Then I talk a bit about the problems and side effects of this. Afterwards, I want to talk about how you can create your own DeLegacy rules and contribute to the project. Finally, I have some evaluation on what is the impact of this, how many sites can we enable IPv6 for, and a short conclusion. A short note about me, I'm Mynacol. You have the contact information on the site. I'm a PhD student at Ulm University and researching on network security, anonymous communication, such as Tor. And I'm part of the BWNet research project and also part of the network operations team at the university. And aside from the university thing and IPv6, I'm also, a little Nix packages contributor and one of the maintainers of RSS Bridge. So let's talk about the problem or the motivation. In the end, IPv6 will win. This is clear. We are now at 50% usage of clients that access Google. IPv6 will win. The only question is how fast. And I was wondering, how can we make this number go up? How we can make more websites accessible over IPv6 as a client, so not tweaking the website itself, but the client, and without any transition mechanism, without any software component that has to translate IPv6 back into IPv4. How can we do native IPv6 as a client, at least? And the other part of the story is the following. Who of you knows this interstitial? Just raise your hand. Yeah, more or less all of the people here. It's from Cloudflare, one of the biggest CDNs out there. And the interesting thing is Cloudflare is really popular. About 20% of the internet uses Cloudflare. And it supports IPv6 since 2012. But still, many of the sites at Cloudflare don't use IPv6. And the basic idea is we can force these sites to have IPv6. And the same is true for other CDNs. It's just an example. So the basic idea is I fear now the audio is working again. Okay, the basic idea is we modify DNS responses so that the client can connect to the CDN with IPv6. I have a diagram here. It's the basic, how can a client connect to a target? First, it has to resolve the DNS. And in this case, it queries the quad A record of example.com. And this DNS resolver queries the authoritative DNS for example.com, which has a CNAME to example.com.cdn.net. That's a common paradigm. And then the recursive DNS resolver asks the cdn.net name server, what's the quad A record for this domain? And the CDN says, we don't have a quad A record for this. And now we interject after step 3 and rewrite the CNAME so we have IPv6. I will change the picture. Here, the new step 4 is we rewrite example.com.cdn.net with IPv6.cdn.net, which is a domain that points to the same CDN but has a quad A record. And then we get the quad A record back, transmit it to the client, and the client can connect to the CDN with IPv6. That's the basic idea here. Any questions so far? Do you understand this? Okay, looks good. Then a quick note here. Not all websites are set up like this. There are multiple ways. I've noted 4 here. First off, you can just use a CDN-provided domain, for example, tosmota.github.io. Then it's clear that GitHub handles all the name server and CDN functionality. Then we have the example we've just seen. You delegate a subdomain with a CNAME or a name or alias to a CDN-provided domain, for example, as seen before, and also www.cdf.de CNAMEs to Akamai internal DNS name for zdf.de. And for these two cases, we can redirect the service domains in the background to another service domain that has Quad A records. And then we have two other ways this can go. You delegate via static or fixed IP addresses. This can also be done at GitHub Pages, for example, but also in the case of Figma.com, it's probably what happens in the background. And that's the most popular way Cloudflare domains are set up, is you just transfer the authoritative DNS name server to the CDN, and it handles all the DNS and CDN functionality. And in the latter two cases, we have no CNAME, no common domain we can match and redirect. And in this case, we can use DNSX4 as we see in a second. Before we go into the implementation, a quick note, this is not something I found. Some other people have found this before me, and also Miuru, another developer, has implemented a software called IPv6 DNS server, which is a Node.js stub DNS resolver, which has a lot of custom logic and handles a lot of CDNs and services. So there is more Quad A records and more IPv6 in the world. So this was already here. And the thing I did was to use, where possible, standard DNS functionality that is hopefully portable between DNS resolvers, and migrate these rules and also, of course, find new rules. So that's the DeLegacy RPZ project. You can find the repository on Codeberg. The URL is here and also linked in the talk description. Yeah, always welcome for contributions, of course. And now I want to talk a bit more about the implementation and how this is actually working in the background. Maybe you're not aware of DNS response policy zones, but it's a more or less standardized way to rewrite DNS responses just by having a DNS zone in a specific format. It is more or less supported by bind, unbound, not, and power DNS, so we are quite portable here. And we can match on a query name, on the response IP address, on name servers or client IP addresses. And the actions we can take is, and the usual way response policy zones are used is to block the domain because it's malicious or something like that. We can drop the request, pass through, so we ignore this domain. And we can also introduce local data. So, and that is the case in how I use the response policy zones. So we match on a query name and introduce local data. In effect, we just rewrite DNS responses to another CNAME. You can find more info on our website there. And at the bottom here, you can see one actual, or two actual rules in the project. We match with a wildcard, in this case, on star.cdn.cloudflare.net. and CNAME it to one of those domains that we know it has Quad A records, in this case, cloudflare.net.cdn.cloudflare.net. That's the actual internal name of one domain that works. And the second rule is just to exempt this specific domain name from the wildcard above. So we have RPZ pass-through in this case. And that brings us quite a way, but not entirely, we cannot entirely handle this. We have Akamai as one other CDN that's quite big and recognized. And they have a slightly different setup internally and how users delegate stuff to them. And they don't use Anycast as in the case of Cloudflare, but they use unicast addresses and use GeoDNS to direct users to nearby CDN servers. And an example CNAME chain here is www.nvidia.com, CNAME to Akamai internal DNS name, edgekey.net is from them. And that is CNAMEd to some identifier.a.akamaiedge.net. And that has an A record, but of course no quad A record, which we want to fix. And yeah, one of the other people in the internet found out that those types of domains are IPv6, IPv4 only, but there is a dual stack variant where you replace the A with DSCA. So DSC might stand for dual stack client or something like that. And then you have a one-to-one mapping for each of those domains to one of the domains that has also IPv6. The interesting thing is this prefix, in this case E33907, has to match. We cannot just CNAME something .a.akamai.net to dsca.akamai.net or also one of the servers inside of this DSCA namespace, 1, 2, 3, 4, 5 or something like that. If we do, we get a certificate error, and if we ignore that, we get an error message that this domain cannot be found. So you have to really direct the traffic to the right server to handle it, and for this we have to match this prefix here. And I wasn't aware before, but this is exactly what DNAMEs do. They are more or less like CNAMEs, but don't delegate one specific domain to another, but a full subdomain tree. So I have an example here, source.net with a DNAME to target.net. And if you have a query for a.b.source.net, it creates a synthesized CNAME record on the fly that CNAMEs a.b.source.net to a.b.target.net. So the left part, in this case a.b, is copied over or taken over to the target.net source tree. And that is exactly what we want. So in the end, we have a rule that's star.a.akamaiedge.net to star.dsca.akamaiedge.net. The problem is DNAMEs are not supported in DNS response policy zones. The reason is there would be unsolved precedence rules between CNAMEs that are in the global DNS and DNAMEs that are in the response policy zone and vice versa. So that was never really cleared, and all the implementations in the DNS servers just ignore or error out on DNAMEs if they are in response policy zones. So we just cannot use it in this format. As a workaround, we can introduce those subdomains as primary zones and just say we know what to do with them and have one record which is just a DNAME to the other corresponding domain, and we are in business again. It's a bit more complicated to set up, but it works. These methods are for translating some common source names to some different domain names. And now we have a method that works on IP addresses. And we just use DNS64. So if you're not familiar with this, we can match on IP addresses and not on names. So we can catch setups that use static IPs, CNAME flattening, ANAME alias, stuff like that. And it's specified in RFC 6147, and it maps IPv4 addresses in IPv6 addresses, often enough in /96 subnets, and often the well-known prefix 64FF9B /96. And as an example, this IPv4 address would be translated to this IPv6 address. And we want to use this, but not with a private IPv6 prefix where we route this to a plat that translates it back to IPv4 at some point in the chain, but to translate it to working global unicast addresses that we can route to the CDNs and they handle the rest. That's the idea. So in this case, some CDNs answer on any IPv6 in a prefix. In the case of Cloudflare and AWS CloudFront, we have such rules. And you have to find 1/64, and then you make a rule, and everything in IPv4 where you know the prefix, you can translate into IPv6 with some suffix which we don't care for, and also the CDNs don't care for in this case. And so we can just translate IP addresses. Exactly. So I have an example here with Cloudflare IPv4 address, and we translate it to the 26064700 and then the IPv4 prefix, and that just works. The setup in bind is as follows. We make an ACL where we can specify the IPv4 prefixes that we want to match for. And then we make the DNS64 rule with the prefix and constrain it to this ACL. This is really cool. The downside is only bind, as far as I know, offers this functionality to restrict DNS64 to specific IPv4 prefixes. And another downside is you cannot exempt some specific domain names from this functionality that have problems when you access them over IPv6. The only workaround I found was to introduce knowingly broken IPv6 addresses, because then the DNS64 functionality is not activated because there is an IPv6 address. But then we have to rely on happy eyeballs and retries from the clients to fall back to IPv4 at some point. That's not great, of course. In the end, that's a list of all the services we support in some way or another, in some capacity or another. All the major CDNs, some object storage, which is quite easy and uncomplicated, some smaller projects and functions. And no, I cannot translate github.com to have IPv6. I'm sorry. I have a backup slide if you're interested in that. Right. Some open problems, I've already hinted at them. DNAMEs are not supported in response policy zones, which is a bummer. That would be really cool if we would standardize this and implement this in the resolvers. That would help quite a lot here. The workaround is to just set up those zones as primary zones in your DNS resolver, and then you're in business again. Then we have a lot of domains that don't redirect with CNAMEs, but by using static IP addresses and the like. And there we theoretically can match on them with an RPZ IP syntax. But the problem is it only matches on A queries, because then we can match on the A query. If we have a separate quad A query at the same time, we cannot match on the A record because the quad A query has no response. One way we could make this work is that cached redirects that were matched on the IPv4 address are cached for the domain that was queried. And then if a second quad A query is coming in, this cached redirect could be used and then fill in the quad A record. But that's probably a very unusual and not really wanted way to use response policy zones, so I'm not sure that will be implemented. And here the workaround is to use DNS64 where possible. And then we have some CDNs where a more complicated logic is needed. For example, for Fastly, the IPv6 DNS server project has a somewhat complicated modulo 256 calculation on the IPv4 address to build IPv6 addresses, and we cannot translate this to a working config that works with such standardized functionality in DNS servers. There is just no portable Lua scripting language that we can use here. All right, then I want to come to the side effects. If you want to use this, I hope you don't really try to read the left side. There I want to access a podcast file, and one of the intermediate servers is accessed over IPv6, which was not intended, and it responds with an HTTP 502 response with internal server error. And the funny thing is, this happens on the IPv6 bus podcast because their hoster has this broken functionality. That's a bummer. And in fact, I think the domain is for inserting ads into the podcast, and they want to use the client IP address to use GeoDNS to insert relevant ads. But because we are using IPv6, they cannot pass the client IPv6 address because they expect an IPv4 address, and we get an internal server error in return. This can be exempted in the RPZ case, but if we also use DNSX4, as I said, we cannot exempt specific domains from this. So I have some problems based on which device I'm using to access the podcast. That's quite unfortunate. Another example is from Springer, one of the research publishers. And if you don't exempt them, they just enter a redirect loop 50 times, and then Firefox gives up and says the page isn't redirecting anymore properly. And again, we can exempt this in the RPZ case, but in the case of the Cloudflare DNSX4, because they use Cloudflare, we cannot exempt a specific domain, and we have the breakage again. And finally, I think the most humorous response here is if you want to access x.com, you get a plain text response with IPv6. If you want to access them over IPv6. In fact, some months ago, they didn't block this, and you could browse x.com or twitter.com via IPv6 after they just moved to Cloudflare. But now they catch this and just refuse to respond with this funny error message. Cool. Then we come to the next chapter here, which is some open source intelligence stuff. How can we learn more about the internals of CDNs, and how can we use that to make new rules to further the IPv6 goal. The first thing is IPv4. That's a really cool add-on you can install in your browser, and then you have this small symbol in the top here, and it shows if the primary domain you're accessing is accessed over IPv4 or IPv6, and there are two small other numbers that show which included resources are accessed over IPv4 or IPv6, and you can expand this, and you get this a big list of domains, and you have an easy way to tell if you are accessing your GitLab via IPv6 or not. And this helps in other cases as well. I found that one of our GitLab servers at the university was misconfigured, and you couldn't access it over IPv6. And all the browsers were falling back to IPv4 with happy eyeboards, and nobody noticed until I noticed, hey, why I am accessing this over IPv4? I know that should have IPv6. And I contacted the administrator, and he fixed it in no time. So that's really cool to have a view of what sites support IPv6 and what sites don't. Right. Then some other OSINT sources I grouped here. Of course, look at the similar project from Yuru. If he has already made the work to figure out how to convince CDNs to use IPv6, just copy the functionality. That's how I started, and a lot of the rules came to be. And then I found some other ones. Search the documentation of the service of the CDN, how the delegation setup works, because they have to document that part. Then if you have some interesting domain, you can get IP prefixes from, I lost my point here. You can often get IP prefixes from the services and CDNs, and you can just look up what ASNs they use, what routing entries they have, and often enough I use bgp.he.net for this. Also search the Trunco and the certificate transparency logs lists for service subdomains. That's how we found this internal cachefly domain to add a rule for cachefly. A small CDN you never heard about, but that's how I learned about it. Then one really cool thing that's rather new, also on Hurricane Electric, the bgp.he.net website, there is a certs tab, and there you can get all the, so you insert an IP prefix, and you get all the certificates and all the IP addresses these IPs they relate to, so all the domains that direct traffic to this to the IPs in this IP prefix, and all through the power of certificate transparency. And finally, one website that's sometimes of use is this here. There you can do reverse DNS, but not on the public DNS, but on actual query data from some people. So you get the reverse DNS of stuff you are maybe not intended to, and stuff that's not directly linked in the DNS system. Right. So the usual way to do this is you notice a website lacks IPv6 and you want to change that via IPv4. Then you look up if it uses a CDN by using GeoIP lookup or one of the websites to get the ASN it is hosted at to figure out if it uses a CDN and which CDN. And then you look if it uses CNAME delegation with DIG or drill or something like that. And then you have to find a replacement domain. Some time ago, we had this cloudflare.net.cdn.cloudflare.net domain. Some of that sort you have to find. There are these reverse DNS websites, and the certificate transparency logs and stuff like that can help you to find such replacement domains that have IPv6 set up. And as I've written. And then you can try connecting using IPv6. curl has a neat functionality. You want to download example.com, and you add this resolve equals example.com, port number 443, and then an IP address, in this case an IPv6 address. And it temporarily uses this IPv6 address for the connection to example.com. So you don't have to modify your host file for a second, try to connect, and then remove this entry again, but just use curl for it. And that's it. You create an RP set rule. All right. Now we come to the evaluation. How can we figure out what impact this has? How can we figure out what websites we are hitting and improving by using IPv6? And I used the full Trunco list with subdomains for this. An ID of the exact list is written here, and it currently has 6.8 million domains, and I just queried them all. I used bind as recursive resolver and queried all the A and quad A records in 2 views. One vanilla, just recursive resolver as you would at home, and one with different setups. In some points, in some cases, I have only the response policy zone set up. In another case, I have the response policy zone and the DNames using primary zones for this. And in some cases, I additionally add DNS64 configs to have the full package, if you will. And the CDNs are detected by their domain names, just like the response policy zone does, and by IP prefixes, just like DNS64 uses. As I said, often you get full IP prefix lists from the CDNs themselves, so you can match what domains you are testing are using the CDN, and you don't catch by name, but just by IP address. And then I did a statistical analysis on the amount of additional quad A records we have here for the top 100, 1,000, 10,000, 100,000, 1 million, and then 6.8 million domains to have some more detail here. I didn't test to connect to those quad A records, so there could be server errors introduced, there could be other breakage that you cannot connect for some reason. I didn't test that. And also, I obviously ignored all the services I don't handle. And yeah, that's it. First off, before I come to my project, I have the popularity of the services I studied. Here you have the percentage of all the handled services in my evaluation. For the top 100 domains in the Trunco list, we have 36% of those that use CDNs that use Cloudflare, 10% use AWS CloudFront, 15% use Akamai, 21% use Fastly, and 15% of them use GitHub, in fact. And the same is true for the top 1,000 and so on. And you see, if you take the top 1 million or top 6.8 million addresses, 71.4% of those that use CDNs are using Cloudflare. So this is really a dominant player. We see this again in a second. Right. Now we come to how the response policy zone and the DNames and the DNS64 performs and how many quad A records it adds to this list that's displayed here. So at the top 100, we have small improvements attributed to DName and DNS64. And as you see over time, the improvements of the response policy zone and also of the DNames is rather small compared to DNS64. This really knocks out the ball in, I think, the top 10K or 100K. I think the top 10K, and the total additional quad A records we have is about at 10%. So reasonable high, but also not groundbreaking. You cannot just turn IPv4 off in your network if you want to use the wider internet. All right, now I also split this per CDN or service, so we have a look at that. You can see that here. In the case of Cloudflare, we have to say, so I split this into the top 100K and the top 6.8 million addresses. In both cases, most of the domains in the Trunco list have quad A records already, and we can fill up the rest with the DNS64 functionality. A similar case is in CloudFront, but here the default quad A usage or adoption is quite low. We have 25% and 38%, depending on the sample size. And we can improve this a bit with the response policy zone, which is actually one single RPZ rule. It's really cool. but the majority again is from DNS 6.4, and we can just bring this to 100%. Of course, because I use the same IP prefixes for the evaluation as for the DNS 6.4 functionality. So in the end, we always come to 100% if we have a DNS 6.4 word here. In the case of Akamai, as I explained earlier, the response policy zone doesn't work like that. We cannot really do response policy zone rules because we cannot add DNAME records to it. But if we add DNAME records as primary zones, we can quite substantially increase the IPv6 usage here. And in this case and all the other cases, I haven't found a working DNS 6.4 rule or IP prefix that brings us to higher numbers. In Fastly's case, the vanilla adoption is also rather low, with 20% IPv6 usage, and we can quite very reasonably increase this with the response policy zone. They have quite a complicated way of using internal names, and there are many ways to set this up. There are common names you can use, but you can also use a map name that has custom TLS settings and stuff like that. And also you can use static IP addresses. So there are a lot of ways you can set up your Fastly delegation. And with the response policy zone, we can catch quite some of them. And then I didn't notice before I made this evaluation, GitHub is quite important in the list of domain names. I think there are also some AWS resources from them, some Fastly resources there. All the domains that are on GitHub pages, for example. And we can actually increase this with dnames. I haven't looked into it why that is the case, but it's rather interesting. All right. The cool thing I think this project is doing, we have a subversive method to force our way into more IPv6 traffic, and we just have to modify our DNS resolver for it. No extra service we have to run. And it's one of the only times we force the service operators that are so far IPv4 only to handle this in some way or another. Because we now connect over IPv6, which was not intended, and now they have to handle client IP addresses that are not IPv4 but IPv6. In some cases, this leads to errors, as we've seen earlier. In some cases, they just block all IPv6 traffic, but they have to handle it in some way. That's a new thing, I think. The CDNs, as the middleman in all of this, could prevent this method, similar to how some of them prevent domain fronting. But at the same time, for now, I see no reason that they introduce prevention methods here. But if this becomes a real problem of the customers of the CDN, so the actual operators, they might reverse and block this functionality, and then we cannot really do anything about it. If you want to try this out, during the GPN, we have a public recursive resolver with all the tricks I've shown you with response policy zone, DNAME, and DNS 6.4. And you can find it at the domain name here with just port 53, DNS over TLS, DNS over HTTPS, to insert it into your Android, into your web browser to try it out. Use IPv4 to get a sense of what websites have IPv6 that previously didn't. For example, at least the homepage and stuff like that of Discord, for example, now works over IPv6. I deleted my Discord account quite some years ago, so I cannot really test if the login still works, but yeah, try it out. And if something breaks, something at Discord broke and they have to fix it in some way. And if you are on NixOS and you want to use this more elaborately, there is an included flake you can just add to your config, and then there are some convenience functions to enable the response policy zone, the DNames for specific CDNs, for Akamai, for example, and the DNS64 for Cloudflare and CloudFront again. And if not, you can set up and configure bind or unbound as documented. We don't have documentation for other DNS servers yet. Here the setup is for unbound, which is really neat. I have the bind setup on the next page. A bit more convoluted, but as I said, bind is at the same time more powerful because we can do the DNS64 setup. So here you add this response policy zone rule, and then you have to add the response policy zone as a zone, again, as a secondary. So you fetch this from via zone transfers from a primary server that hosts the zone. And on the right side, I have the DNS64 setup again. So we have ACLs with the IPv4 prefixes for Cloudflare and CloudFront, of course, cropped in this case. And then we just add DNS64 rules for each of the CDNs here. And the DNS setup is a bit more complicated. You have to add a zone file manually and specify this as a primary zone. You can read about this in the documentation. And if there's lacking something, please raise an issue, contribute by improving the documentation, as I also have written here. We want to support more services, of course. We want to improve the coverage of existing services, ideally by adding DNS64 if we find this. I fear for Fastly this won't work in the same way, and I fear for Akamai as well. So maybe we found already most of the things we can find here. We can always extend the documentation. You can also help there. And what we really would like to have is automatic testing of the existing rules. Do they still work as intended? Stuff like that. And what really would help to drive adoption and also reduce the error proneness here is to have support in bind to exempt specific domains from DNS64. This way we could really use this by default and just exempt the few sites that don't work over this. And finally, what we have on our agenda is to add easy to install packages for OpenWRT or other Linux distros similar to NixOS, so you can just apt install the rule set and somehow this is set up and works out of the box. And one funny thing I thought about the last days, again, you can express CNAME redirects in AdBlock Plus block lists. So we could also give out an AdBlock Plus list you can add to your uBlock origin, and your browser just does all the work. And I find that really neat because you don't have to modify any DNS servers you might not have. All right, then that's it already. If you have any questions, hook me up.
Awesome. Thank you very much. I think that blue screen is on purpose. Yeah. Okay. Great. Do we have questions? We have quite some time for questions. So if you have a question, yes, please raise your hand. I will bring the mic to you. I'm not running, so be patient.
Thank you very much. Very interesting. My question is, do you know if the CDN operators are aware of this work? Seems like some of them already have their infrastructure set up that IPv6 support can easily be added, for example, with the DNS64 method. And have you tried contacting the missing ones and asked them how can we improve IPv6 coverage for your network using this method? Because it seems like some techies might not be opposed to work like that.
If CDNs would be supported in, would be interested in supporting this for themselves, we would not need this DNS64 method. They could introduce alternative DNS zones or DNS resolvers also we can insert and just do the right thing. The DNS64 method is quite a hack that works on some CDNs because they just answer on any IP address in some prefix you send traffic to because they don't care. And why should they? So that's not really how they would do this, I think. And I didn't contact them. I guess they are vaguely aware that this works, but also don't care as long as the customers don't complain. And that's probably the reason they will never enable this by default. It's good that if you add a new domain, they add IPv6 Quad A records by default, and you have to disable this. And this is probably the cause why Cloudflare has such widespread IPv6 support without any modifications. But if there's an enterprise user that doesn't want to use IPv6 Discord, they will offer a method to turn this off and won't make it super easy to circumvent this, at least. And if you want to learn more about the Discord case, you can read up. I think they had a blog entry with, when we first designed the database structure, we allocated 4 bytes for IP addresses, and now it's really hard to change the database in the live system. So we don't want to do this and stay IPv4, at least for some parts of the service. Yep.
Yeah, thank you for that talk. And as you know, I contributed a little bit to your slide number 20 and also to the pre-leading question. Everyone in the audience, if you use services you care about and they don't support, tell them. That is my take on that, to add to that list. Tell them they don't support. Sometimes you get an answer like, we don't care. Oftentimes you get an answer, oh yes, we put it on the backlog or the roadmap, and then they do. We had some domain provider in Germany who was first in that list because we could circumvent it. Begging him, he finally added it.
After a lot of asking back and forth about nagging them, they added it. So,
but if you are a customer at them, tell them. And to the Fastly case, Fastly only supports IPv4 for the alternative name servers. That's another issue.
The work doesn't run out so fast. And also, what I did in a few cases, I noticed that a GitHub page was IPv4 only because they used their own domain name and just inserted the IPv4 addresses. And you can often just create an issue there, ask them to add the Quad A records, and often enough they just do this because you can say nothing will break because it's a static site. Nothing can break. And then, the world is a little bit better.
This might be a stupid question, but why is Cloudflare not at 100% if they support IPv6? And the second question would be, edge case, if you have like GitHub page behind Cloudflare, where in your slide of the statistics would it show up only in the front end of the Cloudflare because it's the front-facing place or whatever, or how would it be in the statistic?
So to your first question, they are not at 100% because if you are a really early customer that created their zone in 2010 or 2012 or something like that, the default back then was to have only IPv4. And you have to manually enable it to add IPv6 because they don't want to break existing workflows, of course. Also, if you are an enterprise or you use the API, I have heard, you can disable this. And some enterprise want to do that, as I said, Discord is one of those cases. That's just the reality. That's why they are not at 100% in the one-in-there setup. To your second question, don't front Cloudflare GitHub pages with Cloudflare, because they already use Fastly. So you have a CDN behind a CDN, which is not helpful. It just makes things worse. But to your actual question, if you front your GitHub pages site with Cloudflare, I will see Cloudflare IP addresses, and most of the findings here were on IP address identification, so it would count to Cloudflare and not to GitHub.
So no content network inception, not recommended.
No.
All right. Any further questions? We have a few more minutes. And there are no stupid questions. You can always ask a question for a friend who's not here, but you might want to ask about something. It's totally fine.
Hi, can you tell us more about your setup for GitHub?
Yes, I hinted at that. So I have this pretty full backup slide here. So we all know GitHub doesn't support IPv6. And some resource subdomains, for example, raw.githubuser.content.com and GitHub Pages, already supports IPv6. In that case, they use Fastly as a CDN before, so it's not really an issue for them. For the main github.com, api.github.com, and so on domains, they use their own AS network. So there is no CDN in the classical sense. And they already have, since quite some years, actually 2 IPv6 prefixes. The main one is this one, a /29 assigned, and also rooted on the public internet. And one of those addresses is also pingable, but it doesn't answer on any TCP ports. I tested it. So this quite sounds to me like, they have some internal setup for IPv6, but are not willing and ready to open this to the public internet. There is some firewall that blocks this, I think. Maybe you've heard in the news that they are trying to migrate to Azure for a lot of their services. And they already started by using VPSs from Azure as load balancers. And they are just random IPv4 addresses in the Azure space. And I have not found a working method to find the IPv6 address they might have on those VPSs, so we can connect to them over IPv6. That might be a possibility. I'm not sure if it will work out. And also, more to the point why they maybe don't want to do this, or by default already, there is this functionality to restrict organizations and stuff like that to IP whitelists. And all those poor corporations would have to add IPv6 whitelists if GitHub would support IPv6. So maybe that's one of the reasons they don't want to support it by default. At least so far.
Yes. Yeah. Thanks for the presentation. Again, a question. Why wouldn't I want to support IP6? So there's TechDep, or recursive things. I have Azure. Maybe Azure doesn't support IP6, and so on and so forth. But are there more business reasons why I wouldn't want to support IP6?
I think they are at the end, or in some cases, just lazy. They still have IPv4 addresses, or they can use Azure IPv4 space now, and they are not quite forced yet to go IPv6, so they cannot really be bugged at the current point to have IPv6. Even though a lot of customers are complaining in the case of GitHub, there is a great issue there, but yeah, that's the word.
on GitHub blocked?
All right.
That's a good question. The question, ask the question again. Come on.
I want who knows why IPv6 is blocked by firewall on GitHub?
So why is it blocked? Do we know why it is blocked?
I think they are not ready to open it up to the wider world, and they, I guess, have some competent networking people as their employees, so they really ensure that it is not reachable at this point in time. If they already have their own ASN, they can just do that and do this successfully.
Any further questions? We still have 3 minutes. If not, are you still around for questions?
Of course, yeah.
Will you stay for the next IPv6 talk that's coming
Yes.
up? Excellent.
It's about IPv4, sorry.
Oh, legacy IP. Okay, I see. Well, in that case, I say thank you very much, and please give another very warm round of applause for Mynacol.
Thank you.